Going to question 21. Which person is experiencing acceleration? How to know? We have situations. Object might move but has no acceleration. When exactly this might happen? If object moves with constant speed in same direction. So if velocity is constant velocity, what does it mean? If the initial velocity, let's say 20 meters per second, and this object keeps on moving with the same speed, same direction, so same velocity, reaching to final velocity of 20 meters per second as well. So comparing initial and final, we notice that velocity doesn't change, doesn't increase, doesn't decrease, stays as it is. In this case, we have no acceleration. Although it moves, although the car is moving or the object is in motion, has a specific velocity, but because velocity doesn't change, that's why we cannot consider we have acceleration. So going based on this description, going to all options, option A, a driver of a car that is braking to stop. Braking to stop, obviously car is slowing down. So there's a change of velocity, which means we have acceleration. Going to option B, a passenger in a train that is stationary in a railway station. Stationary means at rest. Since object is at rest, no motion, no velocity, no acceleration. A shopper in a large store ascending an escalator, which is the stairs that are moving at uniform rate. Again, uniform rate, which is constant velocity, no change of velocity, no acceleration, so it's wrong. A skydiver falling at a constant speed, again same meaning, so all these situations no acceleration is taking place, are experiencing no acceleration because no change of velocity, whether the object is at rest, stationary, or moving with constant speed. Next question is 19. What is the average acceleration of the sprinter between time 2 to 3? In this question we have table. This table is collecting information about different speed and different times, and the question asks about calculating acceleration between 2 and 3 times. So we're going to time between 2 and 3. So obviously this is initial velocity, final velocity, initial time, final time, using our formula VF minus VI TF minus TI. It gives 5.7 minus 4.1 over 3 minus 2 to give A, which is 1.6. Next, a rocket is launching vertically upward from the ground. The rocket travels with uniform acceleration from rest. This keyword helps us to understand what is the initial velocity. From rest means VI is 0, initial velocity of 0 is 0. After 8 seconds, the speed of the rocket is 120. So obviously this is VF final. Calculate the acceleration. Again, VF minus VI over time. We don't have, or we can consider initial time is 0. So we're gonna have 120 minus 0 over 8 to give 15. You don't forget measuring unit meter per second squared. Done. Going to this point, determine the resultant of 2 or more forces acting, which means will be delving into topic 5, Newton's law. Again, as a quick reminder, I'll recap these points before moving on to solve questions. Determine the meaning of resultant force. The meaning of resultant force, which is total force. This in case of having more than one force affecting on the same object. These forces are acting along the same straight line. This means they have to be in the same dimension. This dimension could be horizontal or vertical, which means on the same object we might have forward force and at the same time backward force, or in another situation we might have upward force and at the same time we have downward force. This is the meaning of the same straight line. Let's start answering this question based on this concept. A car engine causes a forward force. So let's consider this is the car engine causes a forward force. It's not mentioned where is the forward force. Is it left or right? So it's up to you. If you are going to consider this is the forward force, so the backward force would be opposite. Or if you're gonna consider this is the forward force, so this would be the back force. So you decide your coordinate. Anyways, going to a car engine causes a forward, so a forward force of 100 kilonewton to act on the car. The total resistive force is 20 kilonewton. What is the resultant force? Obviously, the unit of force is kilonewton. Mainly, our SI unit, which is the standard unit, is Newton. Has to be with Newton. If it's given as kilonewton, you keep it as it is, or you might convert it. But obviously, here all options with kilonewton, so we're gonna keep it as kilonewton. These two forces are one forward, the other one backward. One forward, the other one backward. Two forces acting on the same object in two different directions. To find net force, we have to subtract. So 100 minus 20, it gives 80 kilonewton. Force is a vector quantity, so it requires magnitude and direction. This is the magnitude, which is the number. Where is the direction? Net force is always in the direction to the greatest force. The greatest force is forward, so it will be 80 forward, but it's not mentioned here that you need to identify the direction. I'm just giving you the complete answer just in case. So it has to be 80 kilonewton. If we have option of forward or backward, it's going to be forward, which is to where the greatest force. Next question here. A sledge is pulled in a straight line by dogs, as it's mentioned here. The dogs produce a total horizontal driving force 600 newton. So if we need to use a free body diagram to represent what forces we have here, this will help you just to simplify understanding the situation. 600 newton. The friction force, we know that friction force is always opposite to the direction of motion. If the motion is forward, friction force backward. If the motion is downward, friction force will be upward. So they are always in two opposite directions. Because we know what is the impact of friction force. It slows down the speed of the motion. Anyways, going to this question. So the friction force between the sledge and the surface 150. So it will be 150. Why did I draw it shorter? Because while drawing you have to consider the length. The length shows the magnitude. So 600 is greater than 100, that's why it's taller. and there is an air resistance. So we have two friction forces, friction force between the sledge and the surface, and another friction force caused by air. Kaman has a backward impact as 450 Newton. So we need to find the resultant force. To find the resultant force, step one, you add these two forces. So 450 plus 150, it gives, we can divide it into two steps or one step. So if two steps, number one, you calculate the backward force, which is 600 Newton backward. Now, what is the net force? Now, based on our calculation, we have overall 600 forward and backward 600. So 600 forward minus 600 backward, which means 0 Newton. So this is a balanced situation. When two forces are equal, does it mean that the object is at rest? No. This means the sledge is moving with constant speed. This will take us just a quick explanation about this point. If the net force is 0, this has two meanings. Whether the object is at rest, which means at stationary, no motion at all, no speed, no motion, so no change of speed, which means no acceleration, so net force is 0. The other situation, the object might be in motion, but with constant speed, same direction with constant velocity. Velocity doesn't change. No change of velocity means no acceleration, which means 0 net force, which is our situation here, the sledge situation. Next question talks about same idea, which is calculating net force, but here a box is being lifted by a forklift truck. The weight of the box is 3,000 Newton. We know the weight has to be downward 3,000 Newton. The force exerted by the forklift truck is 3,500. So there's an upward force 3,500. Now these are vertical forces. What is the resultant force? So resultant force, which is net force, obviously these two forces are in two opposite directions, so we are going to subtract 3,000 minus 3,500. It gives 500 Newton. Where is the direction of the force? Is upward. Why did we decide it's upward? Because the upward force is greater than the downward force, so net force is always takes the direction of the greatest force. It's B. Next, same situation, but different scenario. Here, the diagram shows two of the three vertical forces acting on a hot air balloon. The hot air balloon is moving upward at constant speed. So this is our key word, constant speed. Once you see it, automatically this means that the net force is equal to 0, which means that the upward force has to equal downward force. Now go to read the rest of the question. What is the air resistance acting on the hot balloon? So as it's written here, downward force is 2,200 Newton, upward 2,500. So this means these two forces are not equal, but we agreed previously that it has to be equal, which means what do we need to add here? How many what force must be added here, the amount of force must be added to be in equilibrium, to be equal to each other. If you're going to subtract 2,500 minus 2,200, it gives 300 Newton. We need to add more 300 Newton downward to fit the situation of constant speed. This is the purpose. We need to make these two forces equal because we have an evidence here, or our evidence is constant, our keyword is constant speed. So the option will be A, 300 Newton downward. Next, in this question, same idea. A car travels forward along a straight horizontal road. Only the horizontal forces acting on car, just horizontal forces, are represented here. Before going to understand what exactly we need to how to answer this question, have a look here. We have no numbers, no information. The only all information are given as arrows. So we have forward arrow shows driving force, backward arrow shows air resistance. Comparing these two arrows, obviously this is greater than the forward force. Why? Because it's longer. Since it's longer, means it has a greater magnitude. Now, the length of each arrow represents the size. How does the force, how do these forces affect the motion? Since the backward force is greater, so the car moves backward. Let's go to option A. The car moves at constant speed. Not correct, because these two forces not equal. Okay, what about option C? The car slows down. This is the correct option. The car slows down. The car moves backward. No, it's not correct. The car's forward speed increases. Not correct. So the correct option is the car slows down. This is the impact of any friction force. It slows down the speed of the object. Reaching to question 11 means we have covered all the questions related to KPIs, term 1 KPIs that will be included in the final exam.